On slide 5, we dive into our signal processing. So here you can see we're going to take in two input signals. First signal will be signal X, which will be the user's input signal, and signal Y, which will be the signal received from the user's microphone. We'll relate the two signals by taking the autocorrelation of signal X, being the user's input, and the cross-correlation of the user's input and the room volume. Now, the cross-correlation will equal the autocorrelation multiplied by some scaling factor and shifted by a time constant, in this case tau. In order to determine the room noise, we'll have to use this formula down here, correlating the relationship of the room noise and the input signal, the user's input sound signal. So we'll have to solve for the scaling factor and the time constant. Now, in order to determine the time constant can be seen by relating the fact that the autocorrelation peaks at time as t is equal to 0. So therefore, if we find the peak of the cross-correlation, then that time will be the time when the autocorrelation is also peaking, and the time at that point will be the time constant shift of the autocorrelation. To find the scaling factor, that will be a little bit more difficult. In that case, we will take the peak values of the two correlation functions and divide them out, and the multiplier will then be equal to their division. Once we have solved for the scaling factor and the time constant, we can plug it into this formula down here, subtracting the room noise from the user's input multiplied by the scaling factor, shifted by the time constant, and we can get the room noise.